Good evening, friends. Today, let us discuss about LLMs and their hallucinations. Why LLMs hallucinate? Many of us, whoever are using or who have used LLMs in their life, okay, must have experienced this hallucination at some point or the other. There are wide variety of hallucinations that you can experience when you are using LLMs. It can range from imaginary libraries that are created by the LLMs, or it can say penguins invented the internet, or it can say, what is a sun? Sun is just a cheese block, and the sun also speaks Sumerian answer or Sanskrit or something, something. So none of us are immune to these hallucinations. So we will see in this particular video what are the causes of the hallucination and why these LLMs hallucinate and what are the answers to this kind of a problems. Okay, this is again taken from an OpenAI paper which is published on September 5th. Okay, most of the content in this video is taken from this paper. Why language models hallucinate, and we will also add some more interesting things, narration, our own observations, like as before. So, if you want to see the original source, read this paper, and also there are other papers which are taken from, like Anthropic and all. Those are also referenced here. So, let's get into our video. So, what are hallucinations by definition? The hallucinations, by definition, are an important special case of errors produced by language models, which we analyze more generally using a computational learning theory. For example, uh, how many D's are there in a deep seek? Like the in the paper, the experimenter has asked how many D's are there in the word DeepSeek. Okay. I also replicated it. I will also tell what has happened. But if you see, DeepSeek V3 returned 2 and sometimes in 3, non-deterministically. If you are interested to see or understand why LLMs behave non-deterministically, that means time they give a different output. There is a complete video which is done in two languages, English and Telugu. So in the same channel, you can observe them. Okay, you can also follow them. Okay, and sometimes even Meta AI, which is XAI, and also Cloud AI also performed very similarly. So I asked the same question to a Grok over my Twitter handle, on multiple Twitter handles as well. So it answered correctly. That means the Grok 4 has answered correctly. But the Meta AI, which seems 1.5 year also, has done such errors previously as well. So the hallucination is not specific to one model. Hallucination happens every time, or hallucination happens very, very regularly, lesser than you realize. So it looks like, it's not hallucinated, it's perfectly right, but there is a subtle hallucination in the models. Let us see an example. So the example is coming from our thumbnail, Rahul Gandhi and Chota Bheem. Okay. So what I have done is I went to a very popular model and asked, hey boss, how come Rahul Gandhi and Chota Bheem stay at the same age for years and decades? Because if you ask, if you go to Grok or any model, any language model, and ask what is the age of Chota Bheem today, that is in 2025, it will invariably say he is 9 year old. And you can go ahead and ask them, what is the age of Chota Bheem in 2015, 2014, or any time, it will still say 9 year old. So now, if you try to reason with a model or model and say, boss, how come a guy who is in 2015 is the same age at 2025? You will see, like basically it is being presented. So I only read what the documents or web searches say and tell you I don't have anything to think, or I don't have a opinion of my own. That exactly is the cause of hallucination. But the thing which I am presenting you right now is a question I have asked to test the, basically the hallucination of uh, this particular model, because it has, in the recent past, it is not showing the typical behaviors of a model that is lacking the important traits. Okay, it has been becoming very very hard and hard to extract stupid answers from grok. Okay, but still then we know a way how to get them. So this time what I have asked is, I draw a false parallel between the Rahul Gandhi and Chota Bhim, and says both these guys are the same. Okay, because they are not growing up in the age. What is the secret? That's how I probed this particular model. So you can see a decent level of hallucination in multiple explanations of the model. Okay, I did not pick GPT-5 or Llama or Quen or any other large language model, because I wanted to do it with this particular model, which is claiming that they will go to AGI very very soon. So that's why I am interestingly querying and like brute force testing the XAI's Grok model these days. So it has given me a very very interesting answer. You can read the answer, but I don't want to bore you with reading all these things. But what it says is like, it draws certain parallels which are invalid, they because it is called perception building, branding, and context. There is no calendar age and boyish heroism, and they are crafted to they create the imaginary, or the model is creating, or model is hallucinating a imaginary strategy around him to justify the statement, or to justify the proposition that is put before it, you know in terms of prompting. So that is exactly where the hallucination are started. Now, let us see in this particular video what OpenAI paper says, why these hallucinations are coming in, and how do we avoid it. Okay, so that is what is the crux of this particular video. Let's go and watch. So before we understand the reasons of the hallucination, let us understand how LLMs learn to generate whatever it is telling, because it is very important for the listeners and also to the guys to understand how LLMs learn to generate text. If we have to understand what kind of issues uh, LLMs are facing due to its learning. Even for the humans, what you learn in the childhood will etch your character for a large extent, isn't it? So it is very important to understand and learn the LLMs, learn the way, or understand and observe the way LLMs learn the language and the realities. So let's get into a tour, but I will tell this with the help of a story, because it becomes very easier to explain with a story rather than a theory. In this story, the hero, let us call him as Chitty. Okay, Chitty the robot. Okay. So the now the Chitty the robot, when or the Chitty the LLM is first exposed to a lot of books or lot of materials, or we call it as a corpus. Now the corpus can be very very large. It can contain books, it can contain reports, it can contain articles, it can contain code, it can contain repositories, it can contain languages, it can contain Wikipedia pages, and lots and lots of data for this chitty to learn from. Okay. So now this is called pre-training phase of the LLMs. So what they will do is, we will put the chitty, join them into the kind of a school kind of a thing, or a beginner school kind of a thing, and ask the chitti to learn everything by brute force methodology. So how it learns is not the scope of this particular, video, but basically you get what we are trying to do. What do you mean by learning? You have deep learning networks, you have various architectures. We will discuss them in another videos. But when you say learn, think it as a black box learn for this particular video. Now, our boy Chitty starts reading every book, every PDF, every corpus that it is given to, and starts memorizing. And this, it also just doesn't memorize everything. It starts extracting the relationship between the words, and it starts making patterns and the correlations between these words. It also compresses, does a lots and lots of things. So, we will think that as a parallel or a knowledge gaining in a human. But here, when you say you learn, basically, model, identifies what is the weights, what is the biases. Okay. So the basic raw construct of the weights and biases you see in the LLMs will happen here, which is called a pre-training phase of the LLM. Let's take a pause and see what happens next. Now that our robot or LLM robot City has read everything, but what it contains or what it possesses as on date, just after the pre-training is, it contains data points, it contains historical records, it contains statistical information. With some kind of a mathematical capabilities, it can find out what is the trends for a data, what is the sequences for the data, what are the recurring events for the data. It can find out, but it absolutely has no clue how to use this data. Basically, how to use these things which it has figured out from reading a lots and lots of corpus. Now, this is a phase. What happens is, this is a phase our Chitti, the robot, will be given a small mentor. Now, what the mentor is, the mentor, whatever he is trying to do, he is trying to do a fine tuning. Second phase of building an LLM. When a mentor comes to Chitti, the LLM, and what he says is, okay, the data points, how, historical data, statistical data, what is the trends and all. What it will do is the fine tuning scenario. It will give you certain, real tasks and also the examples, solved examples. So now when mentor gives, that is in the fine tuning stage of the LM, mentor gives certain tasks, identified at particular real world tasks and their example outputs. Now is when city starts to form. How do I do things? How do I learn things? How do I do things? What is the question? How do I put all these things? This is the example. This is the right one. This is the wrong one. So, the major part of the intelligence and the character that city is supposed to do is coming in the phase of fine tuning. So, basically, where it is coming? First stage, it learned everything, found out patterns, data points, and everything. And now, in this particular phase, it the mentor has taught the chitti on what kind of a tasks are the examples and what are the out. So basically, he has got the skill set. Now he is seeing the examples like a simulator. Okay. So now here, chitti starts to learn the details of the task and how do they actually perform the task. Sorry, friends, the video is not yet over. LinkedIn cuts the video exactly at 15 minutes. So, if you want to see the remainder of the video, observe for the next post following this, or you can go to the YouTube channel. The link is given in the post, and you can Watch the full video there. Thank you. Now that the supervisor has shown him enough examples and all, now what he will do, or the mentor has shown them all the examples and all, and what they do is now subject the chitty with a supervisor, real supervisor. Okay. Real supervisor here in this case is a mentor. So now he goes ahead and puts the chitty to learn some real world tasks. So now, when Chitti is given real world tasks and there is a supervisor who will see the output of the Chitti, and he starts measuring each of them and start giving the feedback to Chitti on what to do and what not to do. So every time Chitti is given a small task, okay, the output is measured by the supervisor, basically the human. Okay. And then so human rates his ability to do the task. Now, Chitti went through three phases. One, basically it learned everything. And second, by using a mentor, it has saw certain tasks and saw the certain answers. Now it has figured out a way, how do I do the same things if in something new that comes up. And third, in using a human based reinforcement learning system, City does some tasks, some training tasks. So now when it is doing, human will give you the feedback, the model, the feedback and saying this is right, this is wrong. Hey, you have done this right, this is wrong, this is wrong, this is right, this is right, this is right. So this is basically called as a rewarding program. So for every correct task, he will be rewarded good. And for the every wrong task, he will be rewarded 0 points. Sometimes if he doesn't know anything what to do, still he gets a 0 point. So based on that, Chitti will adjust. Okay, if I get this kind of a question, I have to answer this way because my human learning partner has given me something like this and all. So that is where the LLM goes through three phases there. After the third phase, now it's the time to model release. Now update the model, leave it to the people, and that's where Chitti enters the real shop floor. Okay, now that is where the Chitti has transformed itself into a book smart reader. So the bookish knowledge guy to a trainee, and then he is polished. The trainee is, you know, polished as an assistant, and then once the RLHF phase is done, Chitti talks to us like us. That's how a new LLM, LLM professional LLM has come out. That's what is the life cycle of LLMs, more or less LLMs. I have simplified this story a lot for you, uh, just for the discussion sake, but this is how a LLM goes uh, in its life cycle by the time you decide that, yes, now LLM can be trained on or used on a real inference tasks. So that is what a LLM goes through. So, just redefining, I have taken it from one of the Instagram pages. This picture I have taken it from one of the Instagram pages. So if you put all everything that we discussed up till now, this is mostly like this. So you do a massive reading and then the supervisor fine tuning phase, supervised learning, and then the RLHF you go ahead and do. So that's how a LLM is built. Now, where are the sources for the hallucination? Okay. Now is our real challenges. We will discuss about the real challenges, whatever is happening. Now that we know, we do a massive reading here. That is where your challenge number one starts. So your hallucination problem begins all the way from the pre-training phase of the LLM. So not just the pre-training phase of the LLM also have, like many other phases, basically as a summary. If you see, there is a filtering, synthetic data, sometimes you do the mixing, And there are also question and answers from long cortex, a lot of other things. But we did not discuss about them in a lot of detail here because they are not really, the context of this particular video. Okay? If these steps are to be discussed in a different video, we will discuss them in detail. But for now, we have given an overview of what happens because the next steps where we observe why LLMs actually hallucinate needs this context and the story understanding for the listeners, or else you will feel that you are listening to an alien topic. Now let's come to the real questions. Now, what are the pre-training problems which caused the LLM issues? Now that we know the entire process completely, let's go ahead and see what happens or what is the actual thing that is creating. Okay? Now, in most of the corpus you have seen, there is a simple two question problem. Okay. Because most of the corpus, if you want to know a answer, you have to know whether it is a fact or not a fact. No, it's a valid statement or not a valid statement. Yes or no answer. Okay. So if you want to say that, like sometimes most of the models today is trained on only these two questions. But there is a place or there is a question which is outside of this. What if this is not a valid classification itself? What if your training corpus data does not have that information? What if the question is coming from the future? What if is the question? What if your training corpus does not have any reference to what has happened there? Isn't it? Isn't LLM supposed to answer, I don't know? But most of the training methods which today we use does not reward or penalize, I don't know as an answer. So, since from the beginning, LLMs are supposed to be very smart in answering something to the question, I don't know is apparently an non acceptable answer or non rewarding answer in either the fine tuning phase or in the RLHF phase, reinforced learning with a human uh, feedback. So this is one of the major factor why like the hallucination happens. The real cause of hallucination is lying here because model is doing a binary classification of any prompt that you are generating. So that is where the source of the hallucination happens. The hallucination itself may be logical, may be contextual, or may be repetitive. It doesn't have any relationship with the repetitiveness of the hallucination. Although the model is repetitively hallucinating the same, and the cause may be the lack of the answer. So that seems to be the primary cause of concern, very specifically at the birth dates or date of births kind of scenarios. And why does really LLMs generate these kind of answers? To see this, okay, basically to see this and understand this, LLMs to generate a correct answer is very, very hard. Okay. So LLMs can generate a set of different answers and classifying whether the generated answer is correct or wrong is much easier, cheaper, faster than figuring out the correct answer for a prompt or a question. This is a mathematical complexity, and that complexity is generating you the hallucinations. So basically, the way LLMs are generating the answers, the way they are generating and the classifying the answers, giving you output as answers is the factor number two for the hallucinations in the models. The third reason is the way LLMs generate the outputs. Most of the model architectures these days are based on next token prediction. Okay, not a next branch prediction. Okay, so there are some models. Example is sparse model or a mixture of expert model, where the decision depends on which function to activate, and though that function is basically a branching function. So, except for the mixture of experts model, most of the other models base their output or generation on the next token prediction itself. So, if you are doing a next token product prediction, again I refer back to the deterministic LLMs video. There you can see what are the challenges with respect to the repeatability and deterministic have come in. But similar stories come here. So your LLM is not generating a full answer at a go. It is generating the answer in an incremental model. So the token that is created n minus one has definitely a bearing on the current token. Okay. So that is the reason number three for getting into the hallucinations. So if you have to do fix the hallucinations completely, although you may not be able to, you have to address this next token prediction. So the source of the hallucination number three is also in the way a model architecture is designed. The next, reason is called data diffusion. What is data diffusion is when you are training a model, okay, you show a different kind of a data set, but when you are inferencing, your data is completely something altogether. Okay, so that way the hallucination learns one thing and sees another thing. So that is the diffusion. That is a typical diffusion problem. Okay. So sometimes, see the pictorial example. The cat and the dog, if LLM learns to differentiate a cat and a dog just by the color patterns seen in the data, in the training data during the pre-training mod, and if your data, that is presented to you is in a completely different way, dog is presented instead of a cat, then your classification classes may apply to dog that are coming from the cat. Okay. So you may get a dog labeled with a cat breed name. That is hallucination for us, and the source of the hallucination is coming from the data diffusion. So that is one more factor which is adding to the hallucination bucket of the LLMs. So even your training data can also come. Since we are discussing about the training data and the errors in the data as well, so always there is a broad principle in software scenario. Okay, if you could give the garbage in, you will get the garbage out. Okay? It also applies for LLMs. LLMs are not very smart enough to take out the garbage and take only what is the fact. LLMs, in fact, doesn't have a clue about what the ground truth is. So, if you give the garbage in, you expect the garbage as out. Now, in in addition to this, there are another things which are adding to the chain of AI hallucination. So, what are they? There are input data problems. It can be inaccurate, incomplete. It can be even the bias. The data that you are using as a corpus may have survivor bias. It may have confirmation bias. It may have its own echo chamber, data echo chamber. It can be having its own echo chamber. So this, when you feed it to a model processes, it may do a underfitting, overfitting, and even your algorithms may not be bias removing. So all these three are, the contributor for a hallucinated outputs. And when the LLM start hallucinating, there is a break on the trust, break on the compliance, and at the accuracy at this. I will tell you an interesting story. I think we have covered it in our AI news bulletin as well. In one of the Australian case, lawyer, what he has done is he has put out a false citation of the cases, which are basically hallucinated by the LLMs he is using. So when he put those things and without the cross checking, his license has been revoked. Okay. I don't know. I don't remember which week it was, but if you have a habit of checking our AI news, check it out because weekly we post a lot of AI news kind of things, and that is where you can find that particular news as well. So removing the hallucinations as much as possible is very important because it will break the trust on your system. Leave about the compliance side, that is also important, but compliance, accuracy, trust, it's very, very important. So addressing the hallucinations in the AI ecosystems is very important. And that's what we are trying to discuss in this particular video. Is all problems created only in the pre-training or the data? No, you should not, or you need not go ahead and attribute everything. So there are problems which are created after the training is done and the supervised learning is also done. So let us see them also. You are not rewarding the LLM to take the right path. So you have been greedy in where in scoring the LLMs. So the main reason or main output from for the LLMs, what you are expecting is the output. You give a proper output, you give a like quick output, you give output, you generate data, you generate the number of tokens for my reality, and you are not allowed to ask a lot of questions to generate an answer. Have you ever seen any chat model, unless those applications which likes of me go ahead and build, have you seen any general LLM asking you a question before it generates a reasonable answer? No. Why? Because these LLMs are trained not to do so. That is a bigger problem because if something is bad, okay, and you want to clarify, LLMs are not required to do at the supervised or RLHF level. So that is also adding to your hallucinations. Now, whenever you are rating them or rewarding them also has a issue. Comprehensive response, okay? If there is a response and the response is directly accurate or decently accurate, unfortunately, the scoring is not done for the comprehensive responses, or less hallucination response is not given a better reward. And there are no credits if you if the model says, okay, I am not certain of the answer. Okay, nobody is crediting during the RLHF. And if the LLM does not answer when it is not very confident about, or the phrases it is not very confident about, they say the model is a little slow. So, no, and LLMs practically almost at no time ask for you a clarification when it is ambiguous. Okay. So, none of the model architectures as on date are having these kind of features. So basically, as a ecosystem of developers and the consumers, we are actually rewarding the failure. And that is why we see reports that AI deployments fail 95%. No, they don't fail, but we see reports because the perception is in that particular perspective. And the core reason is the way we rate, the way we give the feedback, the way we reward the LLMs. I think that needs a change or a place where we look back into. And most of the LLMs, basically are like MCQ, clueless intermediate student who just came to answer a MCQs. Okay. So now LLMs have no negative marking in the RLHF base or no penalty points for any MCQs which it doesn't answer. So if you see the simple probability answer is, if the LLM guesses an answer and it is right, it will definitely gets a reward. Okay. If the LLM doesn't answer the question, there is no negative marking. So the odds for the LLMs to choose something, even if it is not sure, is good only, is always positive. So if at all LLMs is in a state that, okay, I don't know answer in, I don't know what is the classification, or I don't know whether to tick A, B, or C, or D. But even if I go and put A, I may get a reward if I am right, but I will not lose anything if I am not wrong. So LLMs are rewarded basically to hallucinate. Right? So if you want your models not to hallucinate, you should stop doing that and start encouraging a scenario where I don't know is an acceptable answer. Is that all the answer challenges we have? No, not really. So obviously, while the training methodology and the rewarding things are a steps to make LLMs less hallucinate, and including the model architecture. So if you are using MOE, mixture of experts, the hallucinations may go down, but they don't go to zero. MOE is a methodology where you tend to generate a branch of an answer rather than a pure next token. So, or a sparse model architecture. But the real core reasons are there. There are some reasons which are not discussed, but they are just left open to open interpretation as well. So let's see them as well. So on any given day, LLMs can utter completely nonsense. Okay. The reason is your training data may not have any reference, and you are not rewarding it to say, I don't know, I don't have a clue. And even the algorithms and the mathematical scenarios which are there, like, you know, does not have anything. Okay. So there. So when LLM is forced to do a complete guesswork, it will create hallucination. And that is good as well. Because all the future events, you are supposed to do a hallucination. And the performance of the, thumbnails or the image generation, they are all coming from hallucinations only. The creativity part of the LLM is exactly what creating this. Okay. If you have observed, most of the slides which I have used in this particular video are generated using a popular image generation program. So I have given the prompts to generate my slides. So that's how, I'm okay. And most of the times the slides did not come like I expected, but some of the times it hallucinated better than I imagined. So hallucinations is the framework for creativity. But still then, if it does not have any context, it does not have anything in its know-how, it will still hallucinate. Now, there is one more argument. Oh, I do rag, so I will remove the hallucination. And sorry, your rag is not a complete solution to the hallucinations, because rag will only give you if there is a very specific directed answer or directed context in your solution space. Your retriever of the rag must return the relevant chunks, and you should have the relevant knowledge. Only then RAG is the solution. But if you are asking a completely latent question or a latent data or a latent understanding of that, then even RAG won't save you from the hallucination. So latent data is also very, very important. What is a latent data? So I just wanted to give you an explanation. So the indirect reference or a implicit reference to something is called the latent data. Example, again, let's see the example. We have used it with Rahul Gandhi. Rahul Gandhi and Chota Bhim, in reality, there is practically no relation. But the latent indication of both of them, the model there actually use this particular one. And there is a law of trichotomy as well. The law of trichotomy, it can be A less than B equal to B, or A is greater than B. The answer can lie only in these threads. No, it cannot be. In reality, it is something different. So I will give you one more interesting example for you guys. Okay. So I know how the RAG systems work because I worked on many of them. So if you see, I gave a one question just to prove you all guys why RAG is not a solution. Don't come to me and start beating me. Hey, RAG is the solution. RAG is the answer. I'll give you a simple example. Okay. So I prompted Grok again. Okay. I used two places and I said, give me a seaplane itinerary to Vijayawada to Hyderabad. So I gave this knowing that very well RAG will give the Grok a falsified answer. I know that it will give you a falsified answer. You see the response here, which is there. In reality, the system has no connection with the reality. So, what is happening here? The Grok model is referring to some of the documents back through a web search or its own corpus, its own trusted thing, which has gotten information that is not current, and that is stale, and that is basically wrong information. So, the LLM here is hallucinating an impossible option, or the LLM itself went ahead and hallucinated, and it also created me a hallucinatory itinerary plan, including the costs which are there. So if your RAG search or RAG retrieved data is a garbage, you are going to throw out the garbage out. This is a real world in production hallucination which every one of you can repeat. Try it out. So that is why I say RAG is not a solution. It does offer a method to reduce the hallucination in the overall system, but it can be completely off. This is a classic case of hallucination just because it is looking at some data which is out of the date. Now, one more thing I am really, you know, irritated with the output of this particular model is that although I asked him a seaplane itinerary, it nowhere said, "Are stupid human, traveling through road is directly 300 kilometers. You can directly go. Why are you asking me a seaplane route?" It did not suggest me a regular plane route nor the road route. did not think. If it's a human, okay, they would have said, okay, what you are trying to do is utter nonsense. Stop doing this nonsense. Okay, go back and do this. But LLM in this case has hallucinated that I am very much desperate to do that and give me a itinerary. This is exactly what needs to be changing both in the RAG and also the rewarding methodology of the post training phase of LLM. Now you see why this paper is very, very important. Yes, this paper is a very important, and this paper needs to be understood by almost every AI professional, and everybody who is building a system around AI. So LLM hallucination comes from these many sources. And understand these are the factors that will impact your outcomes. That's all for today, guys. I think you have enjoyed the video. I think you also understand the complications which are there in LLMs producing the hallucinations. I also think you will keep this in mind when you are designing the next AI based systems. As usual, follow Medhuentra, our YouTube channel, and thank you all the followers who have been patiently following us and waiting for the updates. We will ensure more videos are made at a better frequency. But for all those who follow us, thank you very much.